All right, welcome to my software demonstration about how to create a conical model in SolidWorks and for the purpose of developing a flat pattern from it. And so this is the cone that we're going to create. This is the flat pattern that we get out of it. And so then here's the process that we go through to achieve this. So just a little bit of background information about sheet metal parts with conical faces. You must have an edge for a seam, and I'll show you how we're going to accomplish that. We're going to do a revolve with an open sketch, and we're not going to revolve it all the way around. That gives us a little edge there. Any straight sections that we have in our cone has to be tangent to the curve. Like I mentioned, we're going to create an open sketch, and then we're going to revolve it. We're going to revolve at 359.95 degrees. That way it leaves a little seam for us that we could then, once we roll this, that we could fill it in with weld. If that doesn't work, which sometimes it doesn't, we're just going to start subtracting off of this 359.95. And the standard we use is we just subtract 0.05 degrees until it does work. The thin feature depth is going to equal our sheet metal thickness. And so we're going to pull that from the sheet metal gauge table inside of SolidWorks and insert that. So after we do this revolve, then we're going to insert bends. That's what actually creates a sheet metal part out of it, and then it'll flatten out. So here's the process. So the first place it starts with a sketch. So this is the sketch I'm going to go create. So I'm going to go into SolidWorks right now. I'm just going to open up a new part, and I'm going to sketch this. So I've selected a sketch on my front plane, and I'm just going to draw a couple of lines. So I need a line that's going to represent what I'm going to revolve, and then I'm going to add a center line in here as well. That way I can dimension to that, and SolidWorks will pick that up as being my axis of revolution. And so I'm going to dimension from that point to the center line. When I drag out past, that gives me a diameter dimension. So I'm going to make this 5 inches. I'm going to make this a 60-degree angle. So I click on the line, and I click on the point, and SolidWorks gives me kind of this vector looking diagram. So I'll click on this arrow heading to the right. That gives me an angle. I'll make that 60 degrees, and I want this whole thing to be 3 inches tall. So I'll make that 3 inches tall. And then the last thing I need to do is line up my endpoint with my origin to make that horizontal. Now this is fully defined. I like my whole sketch to be fully defined, so I'll put a horizontal relation between the endpoints on these lines. Now it's completely fully defined. I can come on over to features and do revolve. SolidWorks asked me, it says the sketch is open. Do I want to close it? You want to hit no here. You do not want to automatically close this sketch. So we'll hit no. In here, I'm going to type 359.95 degrees for how far I want to revolve that. That way it leaves a little edge right there. For my thin feature, I said I want this to be equal to the thickness out of our sheet metal table. And so where you can find that table, this is what it looks like. And so where you find it, if you need to find it for your software, is you come in through options. And then once your options opens up here, I guess I can't be in a feature to do that. So come in through options, system options, come down to file locations, and then in your show folders for, you'll come on down to sheet metal gauge table, and that will be the file location where your gauge tables are stored. So you can open those up and you can make changes to them so they match your company standard. But once you find it, this is the one we use. It's the sample table steel English units. And so for any given sheet metal gauge, we've got the gauge thickness that SolidWorks uses, and then the bend radiuses that are available as well. So what we're going to make this out of is going to be 16 gauge. So that thickness is 0.0598. So I'll come back here, just need to get back into my revolve. Change this to 359.95 again. And then my thickness, 0.0598. And then I just want to make sure that this thickness is getting added to the correct side. So I want this thickness to go inside. So I'll reverse it. So it's going inside of my sketch. the way I want it. Everything else there looks good. I can hit my green check mark, and now I get a revolve with just a little small edge right there. So then the next step of our process is after we've revolved this, we have 359.95 degrees. We've got our 0.0598 thickness. Next thing's to insert bends. So I'll use that insert bends command. That is a sheet metal tool. It's all the way down here on the end. So the first box is for a fixed face or edge. So I'm just going to zoom in. I'm going to select this edge, and that's going to be my fixed edge. This is my bend radius. I'm just always going to make that bend radius match whatever's in my gauge table. And what we use is the smallest bend radius available, so 0.075 for this one. So that's already set appropriately. Auto relief, we use tear. Everything else there looks good. I can hit my green check mark. And now this thing is a sheet metal part, but you'll notice I've got some errors. And those errors are because of there's not enough room there to insert those bends with the way I revolve this. So when you get an error like this, what you do is go back here to your thin revolve, and I'm just going to try a different number here. So I said start subtracting off 0.05. I just want to see if this is even going to work. So I'm going to do 359.5, and then I'll rebuild this. So by hitting Control Q, I can see it rebuilt. I've got a little gap here, and I can flatten this pattern. So it works. The only issue is with that revolve and how far I revolve it. So through a little bit of trial and error, you can figure out what this should be. And I'm going to do 359.9. Do that, do a Control Q to rebuild. You'll notice how you get that error again. So then one more time, if I change that to 359.85, hit my green check mark, do Control Q again, and rebuild. So that's going to work right there, and that's the tightest cone that I can get with the smallest gap right there. And I can come in here and actually measure that gap. So the gap between these two edges, that looks like it's a little over 6/1000 of an inch. So I think that's a pretty small gap. I think we can fill that in with weld. So that's your process for creating a cone in SolidWorks to be able to develop a flat pattern. So thanks for watching, and good luck in working with sheet metal in SolidWorks. Thanks.